Imagine being stranded miles from shore with your family. The sun is going down, the wind is picking up, and your radio is totally dead.
Oh, that's just the worst.
Right. And all of this is happening because of like a cracked 50-cent piece of rubber tubing. Or, honestly, maybe even more terrifying, imagine turning the key and instead of the engine roaring to life, a spark ignites this dangerous, invisible buildup of gasoline fumes trapped right inside the hull.
Yeah, I mean, that is literally the ultimate boater's nightmare.
It really is.
And the frustrating part, the part that really gets to me is that almost every time you hear a story like that, the root cause wasn't some sudden, unpredictable lightning strike of bad luck.
Right, it wasn't a freak accident.
Exactly. It was just a skipped maintenance check.
So today we are unpacking a really comprehensive annual maintenance program specifically for gasoline-powered boats.
Good, yeah. It's so necessary.
And the mission of this deep dive is to arm you with the exact knowledge you need to protect your massive maritime investment, ensure the safety of absolutely everyone aboard, and, avoid those shocking mechanic bills that can just totally ruin a summer.
Oh, they definitely will.
Because marine machinery can feel like this secret language, right?
Yeah.
And it's a language you really don't want to be trying to learn while you're actively taking on water.
No, definitely not. I can feel super intimidating at first. But understanding that language is crucial because a marine environment is uniquely hostile to machinery.
Hostile is a good word for it.
Yeah, I mean, we are talking about conditions that actively want to tear metal apart. So proactive care isn't just like a suggestion to keep things shiny. It is literally the only way to ensure your peace of mind when you're out there.
Let's unpack that hostile environment first, actually, before we get our hands dirty with the actual engine part.
Sure.
Because it's not like maintaining a car. Like, I always think a car engine lives this pampered, sheltered life on smooth, paved roads.
Right, mostly dry conditions.
Yeah. But a boat engine, on the other hand, is essentially living in a highly corrosive saltwater bath while simultaneously bouncing on a trampoline.
That is a great visual, and that bouncing, salty environment really highlights why the stakes are just so high. Proper maintenance is what prevents breakdowns during what is, let's face it, an incredibly short boating season for most people.
Seriously, you don't want to lose 3 weeks of summer to a broken water pump.
Exactly. And small issues on a boat, they don't stay small. They become very expensive, very fast. Plus, saltwater accelerates corrosion at a rate that is exponentially faster than fresh water.
So tell me about that. Why is saltwater such a ruthless enemy compared to, say, driving your car through a really heavy rainstorm?
Well, it really just comes down to basic chemistry.
Okay.
Saltwater is a fantastic conductor of electricity. So when you introduce different types of metals on a boat,
Like what kinds of metals?
like an aluminum drive and a stainless steel propeller.
Gotcha.
When you put those together into an electrolyte solution like saltwater, it creates a weak battery.
Wait, a literal battery?
Yes, literally. And because of that electrical current, the less noble metal starts to actually sacrifice itself and dissolve away through a process called galvanic corrosion.
Wow. So the boat is basically eating itself alive.
If left untreated, yeah, it really is. This is exactly why corrosion control is such a massive part of maintaining any vessel.
So what does that look like in practice?
It requires, washing down the boat and the trailer immediately after saltwater use, treating metal parts with anti-corrosion spray, and constantly inspecting your fittings for any signs of pitting or leakage.
Man, that's intense.
Yeah.
But beyond just keeping the boat physically intact, there's obviously the safety aspect.
Oh, absolutely.
Because preventive maintenance is directly tied to reliability and safety.
Right.
Like, if you ignore a fuel leak, you aren't just losing money on gas.
Oh, no, not at all.
You are risking a totally life-threatening fume buildup. And, on top of that, a well-maintained engine holds the boat's resale value.
Yeah.
So, in a way, it pays for itself.
It does. It is an investment that protects an investment.
Okay, so if the salt water is dissolving the metal from the outside, the friction of pushing through that water is trying to tear it apart from the inside.
That's a good way to put it.
Let's look at the engine block itself. The sources say oil changes must be done every 100 hours of operation, or annually, whichever comes first.
Yep, that's the golden rule.
And the process is pretty specific. You have to warm the engine up first, drain the oil completely, replace the filter, refill it, and then check the levels.
Right, and warming the engine first is a really critical detail there.
Why is that so important?
Because cold marine oil is incredibly thick. It's almost like syrup.
Oh, wow.
Yeah, so if you don't warm it up, all the sludge, the carbon buildup, and those microscopic metal shavings you're trying to get rid of.
They just stay in there.
Exactly. They just stay stuck to the bottom of the oil pan. Warming it up suspends all that debris in the oil, so it actually drains out completely when you pull the plug.
That makes sense. But I really have to push back on this frequency for a second.
Okay, she.
100 hours sounds like almost nothing. Like in my car, driving 100 hours at highway speeds is, what, only a few weeks of commuting?
Yeah, about that.
If I changed my car's oil every 100 hours, I'd literally be in the shop constantly. Why do marine engines need such a hyper-aggressive schedule?
It's a great question. Think about it this way. When you drive your car on a highway, once you get up to 60 miles an hour, the engine is barely working, right?
Right, it's just cruising.
It's coasting. But a boat doesn't coast, ever.
Oh, because of the water drag.
Exactly. It is constantly pushing against a dense wall of water. It's essentially like driving your car up a steep mountain in first gear while towing a heavy trailer.
Oh my God.
And doing that the entire time you're driving.
That sounds exhausting for an engine.
It is. That constant high load, high RPM environment just shears the molecular structure of the oil so much faster. Plus, you have moisture from the marine environment actively trying to contaminate that oil while it works.
Okay, so 100 hours is basically the safe limit before that oil just gives up and stops protecting the internal component.
Precisely.
Okay, I'm convinced. You're pushing a hill of water. That makes total sense.
Oh.
So what about spark plugs?
Oh, spark plugs are vital.
The sources mention checking their condition every 100 hours and completely replacing them every 300 hours.
Yep.
And the steps are like check the gap with a special tool, inspect them for fouling, which I assume means getting all crusted with carbon, right?
Yeah, carbon crusted, oily, exactly.
Right, so you clean the threads, apply anti-seize compound, and torque them properly. I actually want to pause on that phrase, torque them properly.
Sure.
Is that just mechanic speak for making sure they are, really, really tight?
Actually, no. It's making sure they are precisely tight.
Oh, okay.
Because if you under-tighten a spark plug on a boat engine that is vibrating violently at like 5,000 RPMs, it will vibrate loose.
And what happens then?
Well, you'll have a massive loss of power, and it can potentially just shoot right out of the engine block like a bullet.
Holy cow. Okay, what if I make it super tight then?
If you over-tighten it, you can strip the delicate threads or literally crack the metal engine block itself.
Seriously, just from a spark plug?
Yes, you absolutely need a specialized torque wrench to hit the exact manufacturer's specification. There's no guessing.
And what about that step of applying anti-seize to the threads? What does that do?
We are fighting that corrosion again.
Oh, right, the saltwater air.
Yeah. If you screw a bare metal spark plug into a metal engine block in a damp marine environment and just leave it for a year, it can literally fuse to the engine block.
Like they become one piece of metal.
Exactly. So you go to unscrew it next season and the spark plug just snaps right in half.
Oh no, that sounds like a nightmare.
It is, because now you are paying a mechanic thousands of dollars to pull the whole engine apart just to drill it out. That little dab of anti-seize compound prevents that fusion from happening.
That might be the most valuable tip in this whole deep dive.
It saves a lot of tears, I promise you.
Well, there are also steps here for checking the impeller for wear and tear, testing compression in each cylinder, and greasing all the fittings and pivot points. The impeller, that's that little rubber wheel that pumps cooling water through the engine, right?
Yeah, that's it. And the impeller is arguably the most critical cheap part on the entire boat.
Really? Why is that?
Because if that little rubber wheel gets brittle and breaks, all your cooling water stops flowing instantly.
And boat engines run hot, right?
Super hot. A marine engine will overheat and totally warp its internal metal components in a matter of minutes without that water. It's a tiny part, but it has a massive responsibility.
Wow. Okay, so all that mechanical perfection doesn't mean a thing without fuel.
Nope, you're not going anywhere.
But on a boat, from what I'm reading, the fuel system isn't just about giving the motor power. It is heavily flagged as the #1 safety hazard.
It is. Gasoline on a boat requires a completely different level of respect than the gasoline in your car.
Because it just sits there for so long.
That's a big part of it. Gasoline degrades over time, especially during winter storage. So you have to use a specific marine fuel stabilizer to prevent the fuel from just gumming up.
Yeah, leaving stale winter fuel sitting in a boat engine feels exactly like leaving a half-drunk, sugary soda sitting in a hot car for 6 months.
Oh, that's gross.
But, right, the water evaporates and you're just left with this thick, sticky, useless sludge. So what actually happens inside the delicate parts of the engine, like the carburetor or the fuel injectors? when that degraded, sticky fuel tries to run through the system.
Well, it's actually worse than the soda analogy.
Wait, worse? How?
Because modern fuel doesn't just evaporate. When it sits, especially fuel with ethanol in it, it actively pulls moisture directly out of the humid marine air.
Oh, act like a sponge.
Exactly.
And this leads to something called phase separation.
Phase separation, what is that? Basically, a layer of water and highly corrosive sludge settles at the very bottom of your fuel tank. So when you try to start the boat in the spring, the engine sucks up that water and sludge first.
Yikes.
Yeah. And a carburetor or a fuel injector has passageways inside it that are as thin as a human hair.
Oh, so they just get instantly blocked.
Instantly. That sticky, gummy sludge hits those tiny passageways and completely clogs them. The engine starves for fuel, starts sputtering, or just dies completely on the water.
And then you're stranded.
Yep.
Okay, so on the safety side of things, there is a mandate for rigorous inspection for any signs of fuel leaks, too.
Highly, highly important.
Like checking the fuel lines for cracks or soft spots, checking the tank surface for rust spots, and they suggest using a mirror for tight spaces, which is clever.
Yeah, you got to get back there.
Checking vent lines for blockages, and inspecting the fill hose to see if it's brittle.
Right, because think about it, a fuel leak in a car usually just drips onto the pavement and you drive away from it.
Out of sight, out of mind.
But a fuel leak on a boat drips directly into the enclosed hull right below your feet.
Oh, man.
The fumes build up in the bilge, totally trapped. All it takes is a single tiny spark from the starter motor, and you have a catastrophic explosion.
That is terrifying.
It is. Inspecting those lines and replacing them every 5 years, regardless of how they look, is just non-negotiable.
We also need to look at annual fuel filter replacements. The process involves noting the flow direction, filling the new filters before attaching them, and bleeding the system.
Yes.
Bleeding the system, does that just mean like draining the old fuel out? Or is there a specific mechanical reason for that step?
No, it's actually about removing trapped air.
Trapped air.
Yeah. The mechanical fuel pump relies on suction to pull gas from the tank all the way to the engine. If you introduce a big pocket of air into the line when you change the filter, the pump just spins uselessly.
Oh, because it's trying to grab air instead of liquid?
Exactly. It tries to compress the air instead of pulling the heavy liquid fuel. Bleeding it purges that air bubble so the pump can actually grab the fuel and pressurize the system.
Okay, that makes perfect sense. Let's put ourselves in the shoes of a DIY beginner for a second, just staring at their boat in the driveway.
Okay, I've been there.
How you tackle all this maintenance depends entirely on whether you have an outboard motor bolted to the outside of the back of the boat or an inboard motor built directly inside the hull, right?
Totally different beasts.
So is one of these setups inherently easier to learn on? Because visually, just hanging over the back of the boat to reach an outboard seems, I don't know, slightly less painful than contorting your body into a cramped, dark, sweaty engine hatch to reach an inboard.
You nailed it. Outboards are generally considered much more approachable for a DIY beginner.
Really? Just because they're out in the open?
Pretty much. The entire power head is exposed once you take the cover off. Components like the water pump, that impeller we talked about earlier, are usually much easier to access and replace on an outboard.
But because the lower half of an outboard is physically submerged in the water at all times, they have specific maintenance quirks too, don't they?
They do, like requiring annual lower unit gear lube changes.
Right. And when you drain that gear lube, you aren't just doing a simple oil change, are you?
No, you are doing a really crucial diagnostic check for water intrusion.
What are you looking for?
Well, if the oil comes out looking like a milky brown milkshake.
A milkshake. Oh, that sounds bad.
Very bad. If you see that milkshake texture, you instantly know a prop seal has failed. Water is getting in. And if you don't replace that seal, the water will rust and literally destroy the gears.
Wow.
Outboards also require frequent greasing of the tilt mechanisms.
Oh, just so you can actually lift the heavy motor out of the water?
Exactly. It's a lot of weight pivoting on a small bracket.
Makes sense. There is also a major emphasis on checking the sacrificial anodes frequently on outboards because they wear out much faster, being constantly submerged.
Yes.
And this clicks right back to that chemistry lesson from earlier, doesn't it?
You got it. That weak battery effect.
So what exactly are they?
Sacrificial anodes are just chunks of highly active metal, usually zinc or aluminum, bolted directly to the outboard.
Okay.
Because they are the least noble metal in the water, the galvanic corrosion attacks them first.
Oh, they take the hit.
They literally sacrifice themselves. They dissolve away so your expensive aluminum outboard casing doesn't pit and degrade.
That's incredibly smart design.
It is. You just have to monitor them and replace them when they are about half depleted.
So that's the outboard. What about the inboard, where you're doing the whole contortionist routine?
Right, getting down in the dark.
Those engines are protected from the elements inside the boat, but they have totally different demands.
They do. They require transmission fluid checks, for example, which outboards don't really have in the same way.
Okay.
You also have to service the raw water system, specifically checking the strainers.
Strainers. Like a pasta strainer.
Kind of. These are physical filters that catch seaweed, plastic bags, and debris before the outside water even reaches the engine block to cool it.
Oh, well, they don't clog the whole system up.
Exactly. And you have to meticulously inspect the inboard exhaust systems, too.
The sources mentioned that a leak in an inboard exhaust doesn't just make the boat loud, it actually pumps deadly carbon monoxide directly into the enclosed spaces of the boat where passengers are sitting.
Yeah, that is a highly critical safety distinction.
That's scary.
It is. And beyond the exhaust, there are multiple drive belts to check for cracks and proper tension, which is very similar to maintaining a car engine.
Speaking of different engines, it is interesting to quickly contrast this with diesel engines, even though our main focus today is gas.
Yeah, diesel is a whole other world.
Gas engines need those oil changes every 100 hours, whereas diesels can push to 250 hours, right?
Yeah, they can. But diesels need much more frequent fuel filter changes and valve adjustments at around 500 hours.
While gas engines are the ones that need the spark plug care we just went over.
Right. It really highlights that you just need to know your specific power plant. The tolerances, the stress points, and the maintenance intervals are entirely different depending on the fuel type.
So you can't just apply a gas maintenance schedule to a diesel boat.
No, absolutely not. That would be a disaster.
Okay, so we've got the engine humming and the fuel flowing safely.
Awesome.
But honestly, none of that matters if the boat fills with water or if the battery is just dead.
Right. You're still stranded.
Let's look at the unsung heroes of a safe boat. The bilge pump and the electrical systems.
These are the systems that actually keep the boat floating and functioning when things go totally wrong.
So the maintenance checklist for the bilge pump says these must be tested monthly.
Every month. Yep.
And the instruction is to physically pour water down into the bilge to watch it work.
I know where you're going with this.
I have to admit, I have a major mental block here.
Everyone does.
Pouring water into the bottom of your boat on purpose just feels incredibly wrong. It goes against every single survival instinct I have. Why is this a necessary test? Can I just, I don't know, press the button on the dashboard?
I hear this all the time, but pressing the manual test button on your dashboard only tells you one single thing, that the electric motor inside the pump still spins.
Okay, isn't that enough?
No, because it does absolutely nothing to test the float switch.
Ah, the float switch is what automatically turns it on if I'm like up on the deck and not paying attention.
Exactly. As water rises in the hull, it lifts a little plastic float, which triggers the electrical switch to turn the pump on. But over time, oil, grime, and, dog hair, it all builds up in the bilge.
Right.
That float switch can easily get glued down in the off position by that sticky grime.
Oh, wow. So if a hose clamp fails, the water rises, but the float doesn't move, and the pump never actually turns on.
You got it. By physically pouring a bucket of water in while you are safely tied up at the dock, you are proving that the float actually lifts, the switch engages, the pump has enough power to move the water up and out, and that the discharge hose isn't, clogged with a mud dauber nest or something.
Oh, so it proves the entire sequence works from start to finish.
Exactly. And part of that monthly maintenance is cleaning the switch and clearing out any of that oil or debris.
Okay, consider me convinced. I will pour the water.
Okay.
The other half of this safety net is the electrical system. Moisture causes the vast majority of marine electrical problems, right?
Almost all of them, yeah.
So the routine is cleaning battery terminal connections, annually making sure to disconnect the battery first, obviously, and applying dielectric grease.
Dielectric grease is an absolute lifesaver.
What does that actually do?
It acts as a waterproof, non-conductive barrier, completely covering the electrical connections. So it seals out the salty, moist air so corrosion can't form on the metal terminals and interrupt the voltage.
That's brilliant. You also need to check the voltage. Avoid deep discharging the battery, and the sources say to plan to replace batteries every 3 to 5 years.
Yeah, don't push it past 5 years.
Why not? If it still starts the boat.
Because a weak battery might have just enough surface charge to start the boat at the dock in the morning. But after a day of sitting out in a cove, running the stereo, the fish finder, the bilge pump, the lights,
Oh, it drains down.
yeah, it won't have the deep reserve power needed to actually crank a heavy marine engine to get you home at the end of the day. 3 to 5 years is the safe lifespan before you are basically playing roulette with your power supply.
Okay, so we know what kind of needs doing. Now we need a game plan for when to do it, and crucially, when to put down the wrench and just call a professional.
Right. Structure keeps all of this from becoming totally overwhelming.
So how do we break it down?
Breaking it down seasonally makes it highly manageable. Spring is for your engine care basics, getting it ready for the water.
Makes sense.
Summer is just for quick visual checks between your weekend trips. Fall is for thorough prep and stabilizing the fuel before winter storage.
And winter is when the pros handle the major overhauls while the boat is out of the water anyway.
Exactly. Perfect timing.
I actually like to view this through a kind of medical analogy.
Oh, let's hear it.
DIY boat maintenance is like brushing your teeth and taking your vitamins, right? It's the daily and annual prevention.
Yeah,
But the marine mechanic is the surgeon.
I like that.
Yeah, you don't perform your own surgery to save a few bucks.
Definitely not. DIY is perfect for oil changes, spark plugs, filters, and general cleaning. But crossing into surgeon territory is dangerous, and it usually ends up costing way more in the long run.
So how can you, as an owner, tell you're about to cross that line? Like, when does it go from preventative care to making things significantly worse?
You really want to look out for 3 big red flags: specialized tools, diagnostic software, and safety-critical alignment.
Okay, let's break those down. Specialized tools.
If you are watching a YouTube tutorial and it requires a tool you've literally never heard of, put the wrench down.
Fair enough. What about the software?
Modern marine engines, much like modern cars, are heavily computerized.
Right.
If an engine warning light comes on, you can't just guess what's wrong by listening to it anymore. A certified marine mechanic has the proprietary computer software to plug directly into the engine and read exactly which sensor is failing.
You just can't do that in your driveway.
No, you can't.
What about the alignment issue you mentioned?
Think about aligning an inboard engine to the propeller shaft. If that heavy engine is out of alignment by even a fraction of a millimeter...
A fraction of a millimeter.
Yes. The massive rotational force will cause a vibration that will literally tear the fiberglass hull apart over time.
Oh my gosh.
That requires absolute professional precision.
That is definitely surgeon territory.
For sure.
It's also recommended to find mechanics that are specifically certified for your exact engine brand, right? And to check online reviews from other boat operators to find someone reliable.
Yeah, brand certification is huge. A master technician for a Yamaha Outboard might not know the intricate quirks of rebuilding a Volvo Penta inboard.
The knowledge doesn't just transfer over.
Not always. The tolerances, the stress points, and the specialized tools are incredibly brand specific.
Wow. Okay, so we've walked through the high stakes of the saltwater bath, the aggressive engine demands, the ticking time bomb of stale fuel, the bilge tests, and, knowing our own mechanical limits.
We covered a lot of ground.
We did. And we bring all these highly technical steps back to the ultimate payoff, which is the freedom and the joy of actually going boating.
That's what it's all about. Sticking to an annual maintenance schedule is quite literally the difference between a ruined, incredibly expensive weekend stranded on the water and years of safe, reliable memories with your family and friends.
Exactly.
It's about respecting an environment that demands respect and protecting the safety of absolutely everyone aboard.
It's doing the hard work in the driveway so you can just relax on the waves.
Beautifully said.
But, it does leave me with a forward-looking question to ponder, something for you to think about on your next trip.
What's that?
Well, as the marine industry begins shifting toward electric boats, which is happening faster than many realize, how will this age-old ritual of gasoline engine maintenance change?
That's a fascinating thought.
Right. Will we one day actually miss the smell of two-stroke oil, the tactile satisfaction of a perfectly gapped and torqued spark plug, and the hard-earned grease on our hands? Or will we just gladly trade it all the winterizing and the oil changes for the simple convenience of just plugging a cord in at the dock?
I guess we'll have to see.
Keep that in mind next time you're out on the water, watching the sun go down, trusting that 50-cent piece of rubber tubing to get you safely home.